array nesting. For this question, we are given an array and it contains numbers from 0 to n minus 1. So the question is asking us that if the given number array is permutated, so for example, like we have 0 to 6, and each of the element will not be the original order from 0 to 6. Maybe, like for example, it is like a different order, but each of the element will appear only once, right? There's no duplicate in the array. So each of the element, the digit, denotes the next index it is pointing to. So for example, index 1 is 5. It is pointing to index 5. So this will pointing to 6. And then 6 will pointing to, 6 is here, right? Will pointing to 2, and etc. So 2 will pointing to 0 again. So by knowing this, for every single index, we can have a path, right? We can go to the index and then go to the follow the next index, and then it form a path. So until we're gonna see a loop, we're gonna see the element, one element appears again, we're gonna stop. So it is asking what is the longest path we can find for every single index. Okay, so it's the description is a little bit complicated, but let's know it better by using the example. Go through the example. So like I was mentioning before, we have a 0 to 6 index in this case, and this is the value it is permutated to. So for index 0, what is the path? So we are going to follow the number, the next index, 0 denotes us, which is 5. So we go to 5, it's at 6. We go to 6, it goes to 2. And then we go back to 2, it goes back to 0, right? And 0, we have a 5 again. So this is where we see 0, we see the 5 appears in our set again, and we're gonna stop. So how long is the path? How long is the cycle? So we have 5 in here, and we have 6, and we have 2, and then we have 0. So which means like we have 4 numbers in this path, right? And then we're gonna continue index 1, index 2 to follow the same way to see the path. For index 1, it'll be, okay, go to index 4, and then go back to index 1. So basically there are 2 elements in this path. So 2 is less than 4, so currently our maximum path will be still of length 4, right? And then we keep iterating into the entire array for every single index, and then finally we get the maximum of the path, the length of the path that exists in this particular array, which is 4. All right. So like the intuition for this problem is just iterating through every single index and then simulate the path, right? Go to this index and then go to the next one, go to another one until it goes back to itself, right? And then we know that for this index, how long is the path, and then we compare each one of them and then find the maximum. So this will take n squared complexity. So there are one question we need to answer. So it seems that when we do the simulation here, starting from index 0, we go to index 5, go to index 6, and then go to 2, and then go back to 0. It seems it go back to the starting index. So is it always be the case? Because if that is the case, then when we test our whether we need to stop our path, we can just simply test whether the initial index, the starting index, appears again, right? We can just test, okay, so whether this one is the same index before. Until it's not the same, until we see a 0 in here, we know, oh, okay, so now we're gonna start the loop. We're gonna finish the loop. So one of the counter example is it might be 0 go to 5 and then go to 6, right? And then go to 2. And then is it possible for 2 to not go to 0, but instead it go to 6 again or 5 again? So that it's like 0 go to something and then it not go back to loop to 0 again. It go back to looping half the way, like 2, 5, 6, form a loop, inner loop itself. Is it possible? If that is possible, then we cannot use the criteria of checking with the starting index, right? So for this problem, because that we have all unique numbers in here, so thinking about if somehow we have 2 pointing to 6 or 5, which form an inner loop, then which means somebody is pointing to 6, 5, and then there's no one pointing to 0, right? There's not one pointing to 0, but it will going to be 2 pointing to 5, meaning that this will be like 5 in here. So which means both 0 and then 2 pointing to 5, and the value of the array will have duplicates in that case. So in order to avoid the duplicates, this scenario is not possible. It's always going to be somebody needs to point to 5, also be pointed at some point. Somebody needs to point to 0. So in this case, this will be 0. That means it is enough for us to check the starting index to see whether the loop there is a loop in the path or not. So yeah. So by knowing this, let's take a loop at the code. So we can ignore the visited array as for now. We're gonna have a for loop to iterate through every single element of the array, and then we are going to simulate the process where we have the first starting element as num, and then we initialize our length of the path to 1, right? And as long as we keep iterating, we keep using the value of the current index as the next index, and then keep checking whether it equals to the starting element, which is num's I, right? We have this. So we keep overriding the value of num and then keep finding the path. And as long as it's not equals to the starting index, starting element basically. And then we're gonna increment our length. And at the end of the day, if the length is greater than max, then we override our max, we update our max. And we're gonna do this for every single element, starting from 0 to the end of the element in here. So this will give us a correct solution, but it will be less efficient because we're essentially iterating through every single element and then doing another loop iterating through every single element. So it's an n-squared solution. So how do we optimize that? This is where our visited array came into place, because when we visit some element within a loop, in this case 0, 5, 6, and then 2 is within the same loop, right? So we iterate through 0, and then meanwhile we did 2, 5, and then 6. So when the time comes we iterate through 2, we already know that the length of the path contains 2 will be 4, will be the same as 0, will be the same as 5, will be the same as 6, right? So that's where we're gonna, when we visit 0, we're gonna assign 2, 5, 6 index with the same, we denote them as visited, because it's not going to make a difference. We already calculated the same path. So once we done that, then when we iterate through the index, when we see the visited is true, we just continue. We don't actually do any calculation. That saves us the time of iterating through every index. Right? Yeah. And then finally, we're going to return the maximum of the path count.